you, Mr. Kan. That was interesting. Any questions to the speakers? Nothing on the twisted towers to Mr. Karel? Tony?
Yeah, Tony Raphael, Wintech Consultants. Thank you very much for particularly very interesting topics on the measurements, full-scale measurements presented in the last two papers. I'm very curious to know what your recommendation would be. From the presentation, it seems that for the typical 1 to 10 year return period, we're looking at about a 1% damping for a building without that doesn't contain dampers. Are there any measurements of buildings at high amplitudes but still within the elastic range? So I'm not talking about earthquake, but I'm thinking extreme wind loads. What measurements are there, if you have any, from some of these events that could be a good indicator of what damping should be applied in those higher amplitudes?
Tony, was this addressed to any specific speaker, or you'd like us to? Either one of them. Either one. Ken, would you like to answer on any specific measurements? Could you, Tony, could you please just repeat again, please? Maybe Ken would answer.
Okay, the question is, excluding effect of auxiliary dampers in the structure, what, based on any measurements that you may have, what would be the recommended assumption of damping for a building with, say, a 50-year return response?
Without any dampers.
And I'm talking about non-plastic deformation.
Non-plastic deformation, you mean that when you solve as a linear problem, in Japan, at steel structures, the damping ratio is considered 2% against the severe earthquakes and 3% in the reinforced concrete buildings against severe earthquakes. And model of the buildings are considered as a non-linear element. So this hysteresis is also considered as a damping, but as a damping of the structure is considered 2% for steel and 3% for reinforced concrete.
Young, would you like to add something?
Actually, for evaluation of serviceability problem in wind vibrations, Architecture Institute of Japan proposed damping ratios for steel structure 1% and for IC buildings 1.2%. It is still less than the for the damping for seismic cases.
Pass on the mic, Tony.
Yeah, I believe that recommendation by the AIJ is still being debated, and there is evidence to prove that twice those figures will be more appropriate because of assumptions made in these and assumptions made by Professor Tamura and so on do not factor in the a high-low type of excitation. You know, we could talk about that later, but this might actually change, hopefully, in the next year or so.
See any other questions? Here at the front, please.
Steve Howe, PDI. I'm an architect, and I'm also responding. This is regarding the twisters and the loaders and all those kind of things. I'm responding to the client requirements because of that, almost like a fashion these days. But we have been last 3 days talking about sustainability and functionality and all those things. What do you expect? That first question is that all this, you know, the very unique, you know, totally different shape of that super tall buildings, and how far that trend will go, and is it truly that, is that more sustainable than is that we can try to achieve a very simple and but it's more functional towers? That is my questions.
The sustainability aspect, it's maybe is, I think the double curved surfaces will be used more and more on lower ranged, lower buildings also, the 60 to 100 meters, to make environments that are have less windage on street level. Actually, what they are waiting for is finding a good use for the curvatures indeed. At first it starts off as iconic buildings, and then they start trying to make use of the curvatures to improve the sustainability and improve the, decrease the outside surface by rounding off the edges, improving daylighting maybe. I think there will be many uses that will come when the prices are dropping. And we see at the moment, first the very high rise where hardly any curved glass is being used, and actually almost none here in Dubai even in Dubai. On the very small projects it's being initiated, the whole process, but they are growing rapidly together. The gap between the small projects and the very high projects. And no doubt there will be many curves on the very high-rise buildings also that are going to appear, like the wind energizers, as I call them. Well, I must agree it's a bit of a gimmick on most of the buildings, but probably as the prices drop, that will become more feasible and more effective also. I think it will grow, the effect, the application of it in a very big, on a very big scale. It may take another 10 years, but it will come surely. Funny, my twisting buildings, all the twisting buildings and all the figures that you were showing, they were twisting more than my buildings actually.
Okay. We'll have to see in the future how sustainable those twisted buildings will actually, in practical terms. Any other questions on earthquakes analysis, damping, facades? Well, thank you very much. Would you please thank the speakers.